Hello, everybody, and I would like to start by thanking the organization, Heroin, and all the others for putting together this event. And it's a big honor for me to be at this stage again. The last time I've been here was 8 years ago. My first Laracon was also the first Laracon EU, so it's big for me to be here again. Thank you, and I'm Erika Heidi. Today I'll be presenting how to build GitHub Actions in PHP with Minicli, Minicli, as you prefer. So this is how the talk will go. I will start with an overview of GitHub Actions in general, and then I will talk a little bit about Minicli, and then show the demo app, and then I will show how to turn that into a GitHub action. And at the end, there's a lot of reference links. I just published a post on DevTO with all the steps to build that on your own. So let's go, because there's a lot to cover. Let's jump right in. So I'll start with this overview of GitHub Actions, what they are, and how you can use them. So GitHub Actions are a feature from GitHub that allows users to create automated pipelines. So you can run things, basically. You can run like CI/CD pipelines, but it's not just limited to that, because you can also run things on schedule. I will talk about this in a moment. It's very popular to run CI/CD pipelines, of course. So one important thing is that open source repositories get unlimited GitHub Actions, unlimited runs for free, so you can really make use of that. And the GitHub Marketplace has a large collection of GitHub Actions, so you can find there lots of things that are already, for instance, running Composer, running tests, and running CS Fixer. These are things that you may be already familiar with from GitHub, but you can also build your own actions, of course, and that's the really fun part of it. And you can use PHP for that. So just like there are many use cases, of course, but like the common use cases for running quality checks, run tests, but less common use cases for something like Dynacover. This is something that I run with GitHub Actions, and it updates my Twitter header image every 5 minutes with my recent followers and open source sponsors. So you can run pretty much anything that you can containerize with Docker, you can run with GitHub Actions. So there are some important things to understand to make better use of GitHub Actions. 4 components that I think are very important: actions, workflows, triggers, and action secrets. So if you understand how these work, then you can think of better ways to use this feature. So actions are the most important part of it. They are self-contained units of execution. So you can combine these into a workflow. Usually you have one workflow with several actions. They live in dedicated repositories. So if you're going to build a GitHub action, it should live on its own repository. It can live together with an application, but you can also create a repository only with the action itself and installing the application that lives somewhere else. Actions have an action.yml file that defines the configuration for that action, and we're going to see the example later. You can combine your own actions with actions from the marketplace, and you can package, or must be packaged into Docker images, at least for the use case of PHP. There are some different ways to run JavaScript and other apps, but with PHP, you must turn your app into something that can be run with a Docker file. Okay, so what are workflows? Workflows are basically a YML file that configures a series of steps that you're going to run, and it can be triggered by events. We are going to talk about triggers in a moment, actually. But it can be triggered in different ways. Each job can have multiple steps. One workflow can have several jobs. The jobs run in parallel. Inside a job, you can have multiple steps. And the steps share data. So that's the important bit. You can have things that depend on each other. So the first step, for instance, we check out a repository, and then the next step is making a change in that repository, and then in another step, you can actually commit the changes or create a pull request. Just an example, that's what we're gonna build in the demo app. So workflows, they are defined as a YML file that lives in a specific place in your repository, .github/workflows, and they can have any name you want. You can have several workflows in a repository. And yeah, I think I talked everything. Jobs run in parallel. Also, this is important. So you can have a workflow with multiple jobs that run in parallel. Most workflows have only one job with several steps. So this is an example of a common workflow for PHP. It's a bit simplified, so it would fit in the slide. You start with the name of the workflow, then you define when you want it to run. In this case, it will run whenever there is a push to the repo in the main branch. You can also, usually you also have for pull requests as well. And then we have the jobs. So it will use the Ubuntu latest runner. So this is something else. GitHub has a few different runners, and you can run also, you can have actions that run on Windows-based and macOS to test different things. But for most part of it, you're gonna use Ubuntu latest as your runner. And this has 3 steps, actually. So the first one doesn't have a name. It uses actions checkout. It's going to check out the repository. The second step is going to install the dependencies with Composer. And then the third step is going to run the test suite. And you can have others like CSFix and other things, but this is a bit simplified. This workflow usually is already proposed when you go to the Actions tab on your repository. You have a few different examples, and you can use for PHP, for instance. And triggers. So triggers, this is what triggers a workflow, of course. And they can be triggered by events such as pull requests, a new commit, new issues. Also other things like a new comments on an issue, a new issue is created. But they can also run on schedule, and that is something that not everybody knows. I didn't know that. So I only got to know that when I started working on a hackathon for GitHub Actions, and then I thought that was mind-blowing because I could run anything on it. It's like Twitter bots or anything I wanted. And when on schedule, the minimal interval is 5 minutes. So pretty much any small worker, any small apps that you run with cron, you can turn that into a GitHub action. The other thing, last but not less important, is action secrets. So for some actions, you're going to need API tokens and things that you don't want to go public on your workflow file, so you can use action secrets for that. These are encrypted environment variables that are only accessible by GitHub Actions. You can set that from the GitHub repository UI. You go to settings, and then you find action secrets there. You can set that as a repository level, so repository secrets, and you can also create different environments and have these variables set by environment. Okay, so now I'm going to talk a little bit about Minicli. This is how I call it, but you can also call it mini CLI. I see that I know that there is some thing about calling CLI or CLI. I like CLI, but maybe it's because I'm Brazilian. I don't know. It just sounds better for me. Okay, so Minicli is a micro framework for creating PHP applications in a command line. It's very simple and uses a common architecture that has a predefined structure. You can create a one single file application with a callback command, or you can also use a structured app for using controllers. It is dependency-free, which means it doesn't have any dependencies other than for testing. If you require Minicli from another application, then you don't bring anything with it. It's just that, and then you can choose your own dependencies. It's ideal for small cron jobs, for bots, simple workers. I build a lot of things already with that. So, like Rafflebird is a thing for raffling things on Twitter, like gets a random person from the replies, or I also build a Twitch bot and, well, other things, Dynacover and many other things. This is an example of how the command controller looks like. This comes with the application template, and it's just a simple, let's say, echo that you can run help test, and then you see the parameters that you passed. So you have to extend from command controller and implement the handle method. So that's how you implement a command in Minicli. Okay, so, and this is the demo application. It's gonna import posts from dev.to and save them as markdown files. So this code is all on GitHub. You can have a look later, and also the tutorial shows how to build it from scratch. So what it's going to do is it will carry the dev.to API. It will fetch the contents from a user. We are going to specify the user and also where to save. This is important for us later when we want to turn this into a GitHub action. And then it's going to save as markdown file. OK, so let's turn now this into a GitHub action. Exciting. Some things that you're going to ask yourself when you want to turn an application, whether it's Minicli or something else, PHP application, into a GitHub action. And you also have to consider how you're going to use that in a workflow. So what will trigger this action? In our case, we want to pull content from dev.to, so we are going to build a backup of our articles in a repository. I want to create a pull request whenever I have a new article there. So I have a place where I save all my articles on dev.to as a markdown file. So I'm going to run this on schedule once a day. First question answered. The second question, do I need to combine this action with others? Yes, because I want to create a pull request. So we need to first check out the repository where we want the markdown files to be saved. Then we run the application, and then we will generate a diff, right? Because we have new articles, there's going to be a diff, and then we're going to create a pull request with another action. So do I need any repository secrets or environment variables to configure my action? In this case, there are two important things, variables that we need. We need to be able to change easily the user that we want to import, and we also need to change the directory where we want to save this, because we want to do markdown files to go in the directory where we did a checkout of the repository, the destination repository. So there is a diff, and then we can create a pull request. And so yeah, two variables that we need to use as environment variables. Environment variables you can set up either as action secrets or as a workflow environment variable. This can be set in the workflow itself. The last question is, if my action creates output that needs to be persisted, where this content goes? So this was answered by the previous question. We will be creating a pull request, but you could also be uploading, like Dynacover, I upload the image to Twitter, or you could be saving to a database or something else. Okay, so first thing, we need to package the application with Docker. and create a Docker file that is able to run the application with a single command. So this is a Docker file that I used with several different Minicli applications. We are building from the PHP 8.1 CLI image. Then we run the updates and clean, install curl. We're going to need curl for making the requests. Then we're going to install Composer by copying the latest Composer from the Composer image, the Composer official Docker image. Then we're going to copy the application inside the container. This is one way to do it. You could also clone the application. If the application lives in another repository, then you're going to need in this part in the middle, you're going to need to clone the repository and install the application. In our case, it's a simpler application, so everything is self-contained in one repository, the action and the app. So you're going to copy the files and run composer install. And then we set the entry point for this image as php/application/minicli and import dev. This is the command that runs the demo that I showed in a GIF. This is the command that will import your posts from dev.to. Okay, so once you have that and you test the image works, then you can go and create the action.yml file for that image. So this file should be committed to the same repository where the action is. So the same where the Docker file is in this case, because the most important part here is that it runs with Docker and uses the Docker file to build the image. There are other metadata information that you need to set up. If you want to publish your action to the GitHub Marketplace, then you will need to set a few more details, but it's mostly metadata. Then the last thing that you need to do is tagging your action. So you're going to commit your files and you're going to create a tag that you're going to reference from the workflow that you're going to create. Once you have that published, then you can create a workflow. So this is like two slides. It's hard to put code in the slides, right? So this is the first part of it, but it's only file, a single file. We are importing posts from dev, and this is going to run on schedule. So this cron expression is to run at 1 a.m. every day. Then the workflow dispatch directive allows you, when you have this on your workflow, then it allows you to run manually through the GitHub interface. In the Actions tab of your repository, you're going to see there all your workflows, and then you can run manually. That's good for testing and if you want to see if the thing works, right? So then we got the jobs. We have one only job called main, and then it runs on Ubuntu latest. Then we have the steps. The next slide. Okay, so the first is the checkout action. This is an action that is used a lot. Many workflows use this action, is to check out the repository. The repository where the workflow is defined, to be clear, not the action itself, but it can be any repository that you want to save your Markdown files, the dev articles. Then the second step will use the action that you just created. In my case, it's in my Erika Heidi import dev.to, and then there is the tag info, because whenever you release a change to your action, then you have to create a new tag, update your tag, so you can update also the workflows. Then we're going to set two environment variables. dev.to username and app data dir. So the app data dir is important because it's where the Markdown files will be saved, as I mentioned before. And GitHub Workspace is an environment variable that that's always available from workflows. It's where the checkout happens. So the first action there, actions/checkout, uses github.workspace to check out the files for this repository. So we want to save the files in a subdirectory called devto inside the GitHub workspace. This will make sure that we actually have a difference, a diff, between the checkout repo and after we run the app, the markdown files added. And then finally, we can create a pull request with the create pull request action. And you can set a lot of different information, metadata for the pull request, the title description, and finally the token. This is also something that is, every action has this environment variable. It's the token for the GitHub bot that's running the action. So the pull request is created by the GitHub Actions bot. This is the full thing for reference, the full workflow, complete workflow. And then to test the workflow, once you commit the workflow file to your repository, because it has a workflow dispatch trigger, you can come to the Actions tab, and then you can run manually the workflow. So you can test right away if it works. And then if it works, it should, you have a new pull request from GitHub Actions with your any changes, any new posts you have. The first time it's going to bring all your posts, of course. And yeah, so there's 30 files there. But then subsequently, if you have a new article, then it's going to create a pull request individually for every article. Yes. So here is all the links that you need. I'm going to share the slides, of course, later. And this post, I just published it here while I was sitting, waiting for my time. And then there is also the documentation for Minicli, for other things, for the GitHub Actions, and also the code. So you can see all the code from this action there. That was all I had. And there's a lot to cover, but I hope that was like just to give a brush on everything, and then you can find the references. And that's all. Thank you very much for having me. And yeah, that's all.
I got a question.
Okay.
So, Francisco Madeira, this one I can say it. Gotuga is asking / proposing.
Okay.
Take it easy. He's asking if you have in mind a Termwind printer for mini CLI or CLI.
Well, that would be nice to have, definitely. Yes.
So, you need to talk to Francisco, já sabes. I'm asking,
well,
he already knows.
Contributions are always welcome.
And she talks Portuguese, so it's a lot easier.
Yes. Vamos conversar sobre isso.
Yeah. And what's your future plans for mini CLI?
For Minicli. Okay, mini CLI.
Or Minicli.
You can call it whatever you want.
Whatever.
Well, I don't have many plans. What I want to make sure it is still simple all the time. It's still dependency free. That's my main goal, is to still be simple. So, but there's a lot to do yet, but there's always a lot to do in open source. But yes, I don't have many plans. It was something that I created more for fun and as a hobby, and to create my little bots. So it served me well so far, and I just wanted to be simple and maybe use it for teaching PHP for people, because I think I really love to work in the CLI because, like Marcel,
CLI.
In the CLI, it's very simple. There's less things that can go wrong. You don't have to worry about visuals much, right? Much. But then it allows you to learn easily, I think. If you can focus only on the PHP part, then for teaching PHP, I think it's a better way than getting the whole shebang of a web application to teach PHP.
So mini plans.
Mini plans.
Okay. So thanks again for Erika.